Hi guys, so we're going to be moving over to question 2 now. So this is a question 2. Okay, so this is a quadratic sequence. So here you have 321, 290, 261, 234. Right, so the first question is write down the value of the next two terms of the sequence. Okay, so what you can do, since this is a quadratic sequence, we know that the second difference has to be constant, right? 290 minus 321 is going to be negative 31. 261 minus 290 is going to be negative 29. 234 minus 261 is going to be negative 27. And then difference, negative 29 minus a negative 31, that's going to make it positive, which is going to be 31 minus 29, in fact, which is 2. Similar, same thing here. Negative 27 minus a negative 29 is going to be a positive 2. So if you have to use this difference now going forward, you're going to have negative 27 plus 2. So you can have that difference, right? So that's going to make it negative 25. Then you know that means this one, the next term will reduce by 25 to give you 209. Let's just write it, highlight it a different color. So that's the first term that we've calculated. Then the next one, you know, same thing. Second difference is 2. So you add the 2, negative 25 plus 2 is going to be what? Negative 23. Meaning say 209 plus this difference, right? Because you know here this was a reducing, so this is what the difference is. So this is going to give you a 186. Okay, so now we have for 2.1, answer is 209, then followed by 186. Yes, the answer for that. Then the next one is that determine the term of the sequence in the form of Tn is equal to. So we're looking for the equation of the sequence, and they're saying we want it in this form: an squared plus bn plus c. Okay, so let's first thing that we need some equation that we can use to calculate all the different values. So if you have T1 is going to end up being A plus B plus C, right? And what is our first term? Is 221. So which means that this is the first equation that we can use. Secondly, if you take, say T2 minus T1, substitute 2 here and then substitute 1 as we have, you're going to find that the first difference is 3a plus b. Right, you can test that out for yourself, and then if you do the same thing to kind of get what the second difference is, you'll see that the second difference is going to be equal to 2a. So we know that, so the first equation we have is like a plus b plus c is equal to 221, which is the first term. Secondly, we have 3a plus b is going to be equal to what? Negative 31. That's difference. And you know that 2a is equal to 2. So these ones you can just commit to memory, because whenever they ask you, this is, unless they want you to prove it, it's helpful to just exercise on your own, just to know how exactly is it derived. But for most purposes, you can just kind of recall this from memory and apply it. Okay, so let's apply it. So we have that a is equal to 1, right? Because just divide by 2 here. And then you have b is going to be equal to 2 times 1, 3 times 1, negative 31 minus 3 is going to be negative 34. And then c is going to be 221 plus 34 minus 1. So c is going to be 354, which means that your equation is going to be Tn is equal to n squared minus, let's just that, it's going to be n squared minus 34 n plus 354. That is our equation, right? This is 2.12 done. The next one they're asking here that which term of the sequence will have a value of 74, right? So they're saying which term of the sequence will have a value of 74. Okay, so they say the value is going to be 74. Now they're looking, and then we have our equation, right, which is n squared plus, we're going to just substitute what Tn is, and is equal to 74, and just solve that as a normal equation. Now n squared minus 34 n plus 354 is equal to 74. Okay, and n squared minus 34 n, just take this to the side, subtract it, you end up having 280. Am I correct? Okay, you can double check that for yourself. Then you have to factorize here. First thing is that there aren't any factors to take out. Factorizing n squared, you just have n. Factorizing n by n gives you n squared. For factorizing 280, if you think about factors, so you can have, a simple one is just saying 28 times 10, and then using that to derive the other ones. So which is, if you divide by 2 here, you have 14. But then if you divide by 2 here, to make it consistent, you have to have 20. Because that means 14 times 2 times 10 gives you that. So, okay, right. So now we have our possible factors. So we can try and find more factors. We did the same thing here, and then you just divide by 2. You can have 7 times 2, 14. This gives you the same thing. But then you want some factor. We want to choose factors that can add or subtract to give you 34. Right. The sign is the same, which means that the sign is the same, which means that you want, this tells you that the signs have to be the same of these two roots, and this tells you that the signs have to be negative, so you can have a positive. So what you can choose is 20 and 14, because that combination will give you 20 plus 14 is 34, unlike you can get 14 from these other ones. You can get 34 from these other ones. So which means that the order doesn't really matter which side. Okay. You choose 14 and 20. Therefore, for n is equal to 14 or n is equal to 20, that's when our n is equal to 74. So you can already start thinking about how does this if you had to visualize this, how it looks, right? So you can see that our equation is n squared minus 34n plus 354. That tells you that the intercept, when you make n naught, the intercept is 354. So that's going to be the intercept. And then you know now that this is the intercept at 354. And you know that at 14 and 20, it's like 74. So which implies that this, and then you know that it's concave. Which implies it's going to look something like this. Right? Now they're looking for the next term. Okay, so that question is done. So the answer we're looking for is 14 and 20. So then the next one is just they're asking for 2.14, which term of the sequence is the least value. So that's the least value is basically the turning point. So we're looking for this term. But then if we look at our visualization, so we know that it's somewhere between 14 and 20. So the way we can do that, we can just use the knowledge we have of solving for turning points and functions. So we have a situation where we have Tn is equal to an squared plus bn plus c. If you take the first derivative, that's 2an plus b, and you know that the first derivative, where the first derivative is equal to naught, that's your turning point. And then you can just solve for n. But then we already have what a is here. So we have n squared minus 34n. So we have n squared minus, so we have n squared minus 34n. That's our equation, plus the constant. So which means it's going to be 2n minus 34 is equal to 0. That's going to, and if you solve for n, we have 34 divided by 2 is equal to 17, which makes sense, right? Because if you look at this graph, if 17 was here, it makes sense that this would be the turning point. So that's which term in the sequence is the least value, that's the turning point, and then they just looked for the term. They didn't ask what the least value is, so the term is n is equal to 17. But then just for the sake of it, you can just calculate what the turning point is actually. Okay, that's 2.14 done.